Center of gravity is one of the most fundamental concepts for robot design, and it's basically a measure of the stability of the robot. And this is similar to a seesaw where the center of gravity is located in the middle if both the people on the sides of the seesaw weigh the same amount. But say the second person weighs more, then the center of gravity would shift toward the person who weighs more. And ideally, on a robot and on a seesaw, it would be located in equal distance between all points of the robot. So going back to the seesaw here, it's located equally between person one and person two. And on a robot, it would be located somewhere in the center of the robot. If the center of gravity is misplaced, then it can cause the robot to have more weight on one side, and that can cause the robot to start moving in the opposite direction. So say there's a lot of weight on the right side, then the wheel on the right side would have more trouble moving. And so the wheel on the left would start moving more, and the robot would turn toward the right. Or it could also end up falling on its side in the middle of program execution. And that only happens in extreme cases, but it could happen, which is why maintaining a proper center of gravity is important to robot design. Next is wheel selection. And previously in LEGO kits, a wide variety of wheels would be provided. So for example, on the left is a motorcycle wheel with an 81.6 millimeter diameter. And then there's also a medium-sized wheel with roughly a 50 millimeter diameter. And I want you to ask yourself the question, which one is better? Previously, LEGO made a lot of wheels, and on the left here is a motorcycle wheel, which has a 82 millimeter diameter, and on the right is a medium-sized wheel with a 50 millimeter diameter. And there's such a wide variety of wheels, so it might become difficult to figure out which one is the better wheel to choose when you're designing your robot. Do you go with a smaller wheel or do you go with the big wheel? And so larger wheels with their larger diameter are able to provide faster speeds, but because they have a large diameter, they're also lower in accuracy. And this is because the motors, the large motors and small motors, are only able to turn a set amount. Now, that set amount may be very small, like 1 degree, but say you have a motor that's moving 1 degree and that's attached to a very large wheel, then the small 1 degree movement on the motor will cause a very large movement on the wheel. And that basically gives the wheel an error of 1 degree. And when that wheel is large, that means it's going to be more inaccurate since the wheel can vary between moving forward like 0.5 degrees and minus 0.5 degrees. In addition, larger wheels are usually thinner and that makes them more space efficient. So if you have a very large robot and you don't have a lot of space to put your wheels, then larger wheels may be an option. Small wheels, on the other hand, have a smaller diameter, and that allows them to have higher accuracy, but that comes at the cost of slower speeds because one rotation of the motor is going to result in one small rotation of the wheel compared to a really big rotation on larger wheels. And usually they are thicker and take up more space. And this gives you with additional accuracy because you're having more traction with the surface. But if you have a very large robot, then you might not be able to include small wheels. And so fortunately in our kit, there's only one wheel option. And they're the wheels that are provided with Spike Prime. And these have a diameter of 5.6 centimeters, which is a circumference of 17.6 centimeters. That means for every rotation of the motor, this wheel will travel 17.6 centimeters forward. In addition, there are also caster wheels, which provide a third point of contact to the ground. So you have your two wheels on the right and the left, the two big wheels that we just saw. But those two wheels are not enough because on a car, there are always four wheels. On some vehicles, there are three wheels. And in either case, you always have another set of wheels that are providing additional stability either in the back of the vehicle or in the front of the vehicle. And in robots, this can be accomplished with caster wheels. So the image shows a caster wheel that is used in the real world. And there's also a caster wheel provided with Spike. And the benefits of this is that it's able to spin in any direction with low friction. And that it basically just provides some support for the robot to rest on a third point in order to prevent it from tipping. So this is the base robot that I've included the instructions for. And the primary thing that I want to talk about in this video is where the center of gravity is located. So here, the center of gravity is located roughly around here where the large motor starts. And while on a image, this may not be in the middle of the robot, considering that a lot of the weight is located on the back of the robot, where this caster wheel is located, the weight ends up being equally distributed at this center point over here. And so even though this is not located at the center, it is the center of where all the weight is, since this brake is a pretty heavy component where there isn't a whole lot of stuff at the front. So that's why this center of gravity is located slightly toward the back, because that's where most of the weight is. And here on the base robot, the motor is connected to the base of the robot at 3 different points, and that provides increased stability when the motor is moving and holding down the weight. If we didn't connect it at 3 different points, I know they're hard to see here, but if you've built it, then you can look at it on your own. This allows us to be able to freely move the robot without having to worry that the motors are going to collapse during their movement. And this is crucial if you're designing a robot that's going to hold a lot of weight, because you don't want it breaking in the middle of your execution. So more points of contact are better, but you should also keep it within check, because if you have too many points of contact, then that's just unneeded support. So in our case, 3 points of contact are enough to hold just the brake, which is on top. But maybe suppose if you had like an attachment at the front, maybe you need a 4th point of contact. So that's all for this video. Instructions to build this base robot are located on the website, and you can go build it and explore its features more in depth for yourself. And next we'll be looking at programming this robot to do some very simple tasks.